In this video, we'll learn about compositing Octane AOVs in Fusion. We will be using this scene and we are going for a basic back to beauty composite and a relight or light mix composite in Fusion. We'll be using this mixer scene. The color manager is set to ACES. Let's first start a render in the live viewer. I'll just set the resolution scaling 2.5 in the live viewer as the resolution in the render settings is set to 1920 by 1080. And I just want to show you the AOVs that I have already added quickly. Hey folks, welcome to MoGraph Plus. This video is a free sample from our course, The Ultimate Introduction to Octane for Cinema 4D. It's a massive 20-hour long course in which we explore all the aspects of Octane for Cinema 4D thoroughly. Make sure to check it out. The link is in the description. Don't forget to subscribe and hit the bell icon to get notified about our latest videos. Let's also open up the AOV manager from the render settings. First, we have our beauty AOVs, which give us all the essential beauty passes like diffuse, emitters, reflection, refraction, subsurface scattering, and transmission. Next, we have a bunch of light render elements for all the lights in the scene that give us the individual contribution of all the lights in the scene. We have the ambient light and 7 light passes for all the light sources and emissive materials in the scene. We can go through all of them one by one. For the matte or mask AOVs, I have 2 cryptomattes. For one of them, the crypto type is set to material node name, and for the other one, it is set to the geometry node name. With these 2 cryptomattes, we can select and isolate anything that we want in post. I also have a custom AOV that stores the headphone in the red channel, the panels in the green channel, and the buttons in the blue channel. We learned how to work with custom AOVs a few lessons ago, and these are here in case we wanted to select or mask any major element in post. Now, if I open up the Octane settings window, you notice I'm using a fairly high max samples value of 20,000 to get a clean render. I also have spectral AI denoiser enabled in the camera imager for the active camera. Now let's get back to the Cinema 4D render settings window, and to save out the render, let's go to the Render AOV group tab. To get an accurate output with ACES and cryptomatte, the format has to be EXR Octane. 16-bit is a good balance between quality and file size. Save beauty is checked, so the beauty pass will be saved alongside the AOVs. I have also enabled denoised beauty, so the denoised beauty pass will be saved out alongside the regular beauty pass. I normally have the multi-layer file checked, so all the AOVs would be saved to one EXR file and then shuffle out the AOVs in post. But for this lesson, I have it disabled, so each individual AOV will be saved out to a separate EXR file. This will make the job a bit easier for the video recording because we can simply get those passes and EXR files into Fusion and start compositing. And then obviously we need to define where to save out the render. I'll be including the render and all the EXR files in the render folder of the project files. You should be able to find and use them in the renders folder, 05 rendering folder, and finally in the 0505 underscore compositing underscore AOVs underscore in Fusion folder. Now we can press Shift plus R to start a render in the picture viewer. I have already done that, and here is the folder where the EXR files are saved. We have our beauty AOVs. Light pass AOVs. Also the main beauty pass. and the denoised beauty pass, and the 2 cryptomatte, and the 1 custom AOV pass. So let's head over to Fusion and start compositing there. Here we are in Fusion. Now, if you are not familiar with Fusion at all, you are in luck, because I do have a great beginner's guide to Fusion for compositing on Mograph Plus's YouTube channel. The video is called Compositing V-Ray Renders Using Fusion, a Beginner's Guide. Make sure to check that tutorial out before watching this video. I explain Fusion's UI, how to navigate, how to import and work on your footages. I talk about mask, color correction, linear and sRGB color spaces, how to export, and so on. Go watch that tutorial and come back to this video. Now, before bringing in the EXR files, let's go to the File menu and open up the Preferences window. And make sure the color depth is set to 16-bit float, as our footage was rendered in 16-bit float. Now you can save the preferences. Now let's start with a Back to Beauty composite with the Beauty AOVs. So let's select all the Beauty AOVs, including diffuse, emitters, reflection, refraction, SSS, and transmission, and drag them into Fusion. And also select the main beauty pass and drag it in, so we would have a point of reference when the Back to Beauty composite is finished. When you drag multiple files at the same time, Fusion automatically merges all the files together and does most of the job for us without having to do it manually. Let's view the main beauty pass. First in the left view, and press Ctrl F to fit it to the view. Let's view the main beauty render. As we are in ACES, the render does not look correct. We learned how to properly convert and view ACES renders a few lessons back in the ACES video. But if you want to make the view correct for ACES while we are still working on our Back to Beauty composite, the way we did it in the live viewer and actually change the color space in the live viewer to OCIO plus sRGB, all I have to do is to enable this LUT for my view, change it to OCIO color space, and we can now load the proper OCIO config file using this edit button. So we can load the OCIO config file here, change the source space to ACES 2065-1 and output space to sRGB. And now we are looking at the correct beauty render in ACES with an sRGB transform applied. But that is a temporary solution for just while we are working. And at some point we have to do a proper ACES conversion, which we learned before, and we will do it again here. Let's view the beauty pass in the right view as well and enable OCR color space for that view too. For now, let's get back to our beauty AOVs and take a look at them one by one. So here is the reflection AOV. You can just select any node and press 1 to be viewed on the left view or 2 to be viewed on the right view. So here is the reflection AOV, refraction, subsurface scattering, transmission, diffuse, and emitters. Or you can simply drag any node on the left or the right view to view it. Now, there are different nodes to merge and composite AOVs in Fusion. You can use the merge node or the channels Boolean node. So here, when we dragged all the beauty AOVs, Fusion used the merge node to composite them together. We just need to select the merge nodes and zero out the alpha gain, and then that would be it. So let's select the first merge node, which adds the refraction AOV to the reflection AOV. We can view it on the right view and just zero out the alpha gain. Then let's view and select the second merge node. All the merge nodes are already set to be additive, so we don't need to change the blending mode for them. This one adds subsurface scattering, so let's just zero out its alpha gain. Now let's go through the last 3 merge nodes, which add transmission, diffuse, and emitter AOVs, and zero out the alpha gain for all of them. Now, if we view the last merge node on the right side and the separate beauty AOV on the left view, you notice we have recreated the beauty pass by adding the beauty AOVs. But let me delete all the merge nodes and then arrange these nodes horizontally. And let's composite them together using the channels boolean node. So press Ctrl space and add a channel booleans node. Set the reflection pass as the background input and refraction pass as the foreground input. We can view the channel booleans node in the right image viewer. Select the channels boolean node, set the operation or blending mode to add and alpha to do nothing. When doing a back to beauty composite, the order of the AOVs does not matter. And now we have added the reflections AOV to the refraction AOV. Let's copy the channel booleans node, set the previous booleans node as the background, and add the SSS AOV as the foreground. As we just copied the booleans node, the operation is set to add, which is what we want. Now we have added the SSS AOV. Now copy the booleans node again, set the previous booleans node as the background input and the transmission AOV as the foreground. Let's keep going and add diffuse and emitters as well. Now, if we look at the last node in the chain, the beauty render is reconstructed successfully, and we just need to take care of the ACES color space properly. First, let's disable LUT for the right image viewer. I'll keep the left one enabled in case we wanted to see any individual node. Add an OCIO color space node and load the OCIO config file. We learned how and where to download the config file in the ACES lesson in the introduction section of the course. Now connect the last Boolean node to its input. The source is ACES 2065-1 and the output space is ACES CC. Now copy the OCIO color space again and hook it up to the previous OCIO color space node. And in this one, we will go from ACES CC to output sRGB. Now we have properly applied the output transform device to our ACES image if we view the last node. If you are rendering in the built-in linear color space, you don't have to do these conversions. Check out the free YouTube video that I mentioned at the beginning of this lesson where I use a simple linear render and output an sRGB render, which is much simpler. Now, in the ACES videos previously, I explained why we go from ACES CG or ACES 2065-1 to ACES CC and then from ACES CC to sRGB. If you have any question, check that lesson out. But basically ACES CC allows us to color correct in ACES and take advantage of all the benefits of ACES. And then when we are done, we can get back to sRGB. Now we can do all the color correction in between these two OCIO nodes where we are in ACES. That's a lousy explanation if you haven't watched the ACES video yet. Go check that out, people. Now, if we want to apply some sort of color correction to the entire image, we can do it in between these two OCIO color space nodes. Or if we want a specific adjustment to be applied to one of the AOVs, we can apply it after each AOV. The first thing I want to try is to change the color of the headphone from white to something else. If I check all the individual AOVs in the left image viewer, you'd notice that the white color of the headphone is coming from the subsurface scattering AOV mostly. So let's add a color correction after the SSS AOV. And let's view the color correction node in the left viewer and the final result in the right viewer. Now we can select the color correction node and start adding a yellowish orange color tint. Let me set the tint to negative 0.87 and tint strength to 0.57. Next, we want to make sure only the white parts of the headphone will get this color correction and not the entire subsurface scattering AOV. For that, we need to bring in one of our cryptomatte AOVs. Let's go to the render folder and drag in both of the cryptomattes. Let me just delete the merge node. Then I can select my two cryptomatte AOVs. Right-click on them and change their colors to violet so we can distinguish them from the beauty AOVs. This one is the material node name cryptomatte, and this one is the geometry node name. Right now we want to select the parts of the headphone that have this white material, so we can probably use the material node name cryptomatte to isolate that part of the headphone. So let's make a copy of the material node name cryptomatte and put it close to the color correction node after the subsurface scattering AOV. To start using cryptomattes in Fusion, you need to download the cryptomatte plugin for Fusion. Just Google cryptomatte and download it from the cryptomatte GitHub page. You will find instructions on how to install it for Fusion there. Press Ctrl Space and add a cryptomatte node after the cryptomatte AOV and view the cryptomatte node in the left view. And let's disable the checker underlay for this view so we can see the path better. Now simply move this indicator on top of the geometry that you want to make a matte out of, which is this purple color of the matte for us. Then click on this Add button and then change the view mode to matte. Now we have a simple white mask for the white parts of the headphone, and we can use it as our color correction mask input. But before that, because we had some optical vignetting going on back in Cinema 4D, this is not a pure black and white mask. There are some mid values. So let's add a color curves adjustment and just crank up the mid values until we get a fully black and white mask. Now we can use this color curves as the mask input for the color correction node. So there you have it. Now that color correction node only affects the white parts of the headphone. Obviously, the white color is the better choice for the composition, but we are just here to learn a few things quickly. So for now, I'm gonna select the color correction node after the subsurface scattering AOV and probably disable it. Next, let's say we want to address this bright red specular highlight on top of the headphone, and that is obviously coming from the reflection AOV. So first, let's isolate the ear cushion of the headphone. So for that, I'll be using the geometry node name cryptomatte. So let's select it. create a copy and paste it near the reflection AOV. Add a cryptomatte node after it. View the cryptomatte node in the left viewer. We need to place the indicator on top of the ear cushions, and there are two colors that needs to be selected in the cryptomatte so we can isolate the entire ear cushions. Just place the indicator on top of them and press add. And finally, change the view mode to matte. I'm going to add another curve color correction to the cryptomatte so we can crank up the highlights to get a fully black and white mask. Now add a color correction node after the reflection AOV. Use the new curves correction as its mask. View the color correction node in the left and the last node in the chain on the right view so we can see what we are doing. Now I can select the color correction and use the hue adjustment to get another color instead of red. Maybe something green. And you see how we are changing the color of the reflections only where we want on the ear cushions. Or we can zero out the saturation to get white highlights. We can also increase the gain to make those highlights more pronounced. And we can play around with saturation again. For now, let's set the hue to negative 0.56. And saturation can stay at 1. And now we get this nice green reflections that might be more interesting than those red specular highlights. So as you can see, AOVs can be extremely powerful in post and allow you to change anything that you want without having to re-render. Let's apply a color correction node to the entire comp. So add a new color correction node and add it in between those two OCIO color space nodes. So hold down Shift and insert it in between them. And here let's increase the gain to 1.15 and decrease the gamma to 0.9. Now we can view the original beauty pass in the left viewer and the color corrected one in the right viewer. Cool, so we have adjusted a few things here. Now let's quickly go for the relight composite as well. So let's create some free space. Open up the render folder. Now find all the light pass AOVs, which are the ambient light pass and the light IDs 1 through 7. Drag them all in. Let me quickly arrange the nodes horizontally like the beauty AOVs. Then I'm gonna select all the light AOVs and change their color to orange. This time, we will just keep the merge nodes instead of using channels Boolean nodes to combine these light AOVs. If I view the first merge node, which combines the HDR environment and the light pass ID 1, we only see light pass ID 1. If I select the merge node, you notice it is already additive because the subtractive additive slider is set to 1. And if I lower the blend amount from 1 to 0, I'll start to see the lighting from the HDR environment. For now, set the blend amount to 1. And to add the two AOVs, just lower the alpha gain to 0 And now these two light AOVs will be combined properly. Let's go through all the merge nodes, view them, and zero out the alpha gain for all of them. And now the beauty path is recreated and we can relight the scene as we wish. Let me enable the OCI color space LUT for the right image viewer and view the last merge node in the right viewer. Now, for example, let's say I want to adjust the effect of the green light on the scene, which is stored in light ID 1. I can simply add a color correction node after that AOV. Let's view that color correction node in the left viewer. I can use the gain value in the color correction node to adjust the intensity of the light or completely turn it off by setting it to 0. If I want to adjust the color of the light, let me just increase the gain again. I can simply use the hue and saturation sliders. Or if I want to be a white light, I will simply set the saturation amount to 0. For now, let's set the hue to 0, saturation to 1, and let's set the gain to around 0.6. So now it has a lower intensity compared to before. That red light is still bothering me. It is the light that causes those red specular highlights on the headphones ear cushions. The red light is stored in light ID 4 AOV. Let's view it. Add a color correction node after it and view the color correction node. We can start adjusting the hue if we wanted to get a different color. But let me set the hue to 0 and also 0 out the saturation so we get a simple white light source. And maybe we can increase its intensity by setting the gain to something like 1.5. Now if I turn on and off this color correction node, you can see what it has done to our lighting. Then let's take a look at the light ID 5 AOV, which stores this warm orange emitters. Let's add a color correction node after it. View the color correction in the left image viewer, and I'm just gonna increase the gain to around 4 to make it more intense. Now let's go for light ID 6, which stores these smaller, more colorful emitters. Add a color correction node after it. Let's increase the gain to around 4 again and also increase the saturation to 1.2 for more vivid colors. Now, if I view the original beauty path in the left view and the last merge node of the relight composite in the right viewer, you see how we have changed the lighting. Let's disable the LUT for the right viewer. Copy the two OCIO nodes from the back to beauty composite. Paste them at the end of this chain. Connect the last merge node to the first OCI color space and the first OCI color space node to the last one and view it in the right viewer. Let's add another color correction node between these two nodes. increase the gain to 1.075 and decrease gamma to 0.95. That is pretty cool. Let me quickly show you how to use the custom AOV RGB mask that we exported from the renderer as well. Let's get back to the previous composite. And let's say I want to color correct the entire headphone without affecting any other object. You remember we stored the entire headphone in the red channel of the custom AOV 1 pass. Let's bring that AOV in from the render folder. And if we take a look at it in the left viewer, we can see the RGB mask. Let's add a color correction node before the last OCIO node. If I start adjusting the hue, saturation, gain, or anything, they will obviously affect the entire image, but we can define a mask input for the color correction node. So use the custom AOV1 for the color correction mask input. Next, we need to tell the color correction node to use the red channel of the mask. So select the color correction, go to its settings tab, and change the mask channel to red. Now, any color manipulation done through this color correction node will only affect the headphone as you see. For now, let's disable this color correction node as we don't need it. And let's get back to our Back to Beauty composite and save it out. Now let's save out both of these composites. I'm going to view the last node in that chain, in the Back to Beauty composite chain, add a saver node. Save it out in the renders folder, in the 05 rendering section folder. Go to 0515 compositing AOVs in Fusion folder. Name the file 0515 underscore compositing underscore AOVs underscore in underscore fusion.png. Make sure the format is PNG as well and press save. Use the last node as the input for the saver node. Then let's copy the saver node and paste it at the end of the relight composite. Connect the last node of that composite to the input of the saver node. Select the saver node and just change the file name. Just change the file name to 0515 underscore compositing underscore AOVs underscore in underscore fusion underscore relight.png. Restrict the timeline to just one frame by setting all end frame and frame range values to 0 and press render. And then click on this start render button and press render. And after a few seconds, we get this render complete message. And now we can take a look at our renders. In case you are compositing a simple linear sRGB render, you don't need to think about these ACES nodes. In the image viewers, for while you are working, just use a simple Fusion View LUT and edit its gamma to 2.2. And for when you want to save out, just go to your saver node and in the export tab, come down to the output gamma space. Change the curve type to space and gamma type to sRGB. And then you can click on the render button and save out your render. So in this video, we learned about compositing Octane AOVs in Fusion. See you in the next one. Make sure to visit our website mographplus.com and check out our premium CGI and rendering courses for Cinema 4D, 3ds Max, Maya, Arnold, Octane, Corona, V-Ray, Redshift, and much more. See you in the next one.